Hi teachers. If you'd like to try this experiment yourself in your classroom, here are the materials that you'll need. You'll need a tray in which to do this because this can get a little messy and it can stain students' clothing if they're not careful. You'll need some baking soda, some calcium chloride, and a chemical called phenol red. Now this one you'll probably have to order from a chemical supply company. There's a chance your local pool store might have this chemical, and they will probably have calcium chloride. So go to a swimming pool store and ask if they have calcium chloride. You can sometimes find this in automotive stores as well, as it's used to melt the snow on roads in the eastern United States. So calcium chloride can be ordered from a chemical supply company, but you might be able to get it locally. Phenol red, and this is water-based phenol red. You can get it alcohol-based or water-based. The water-based is cheaper and will work fine. And the baking soda are the chemicals you'll need. So technically, it looks like we have 3 chemicals here. We actually have 4. The baking soda, calcium chloride, phenol red, and the water that's in the phenol red. You'll also need a small container, something about that size. You'll need a sandwich baggie and a spoon, and of course your isolating reactions lab sheet. To do the experiment, you start by taking 2 spoonfuls of the calcium chloride and placing them into the baggie. There's 1, and there's 2. Next, I'm going to mix some baking soda into the baggie as well. And we want to see if these 2 chemicals react. And I put them in there. I seal my baggie, trying to get most of the air out. And I mix them together, and nothing happens. Those 2 chemicals do not react by themselves. Now what I'm going to do is add a little bit of the phenol red to this cup. And I want to place that in the baggie carefully so they do not yet mix. So this is where your lab partners can help. One person sets it inside, like so, without spilling. And then they squeeze as much air as possible out of this and then seal it. And you may have one person hold that cup so it doesn't spill while the other person seals the baggie. And again, we want as much air out of that as possible. Now with the baggie sealed tightly, I'm going to dump this upside down and shake it to mix the chemicals, and then we'll set it in the tray to let it react. And one of the first things we notice is that we get a color change in there. We also see that it's foaming up. The bag is starting to inflate. It's filling up with some kind of a gas. And I also notice that the bottom of the bag is getting warm to the touch. So I have a color change, a gas forming, the bubbling, and a temperature change. In fact, if I don't get enough air out of that baggie, it might even pop the baggie. That's the reason we want to do this in a tray. Now we're going to observe something else. I'm going to carefully open the baggie and light a match and try to see what happens when I get flame near to that gas. Here we go. And it extinguishes a match. Whatever gas is in there, it causes that match to go out. Let's see if I can get it to do it again. And there it goes again. Whatever gas is in there, it's not oxygen because it extinguishes a flame. Cleanup for this lab is very easy. You'll simply dump this down the sink, throw the baggie away, and rinse out this container for future use. Did you notice what happened when you cleaned this up in the sink? It turned from yellow back to pink again, didn't it? What do you think caused that to happen? Now we want to find out what caused those separate reactions. We know that when we mix calcium chloride and baking soda by themselves, there is no reaction. But when I added the phenol red and the water, many things happened. A gas formed, it changed colors, there was the bubbling, which was the gas. The gas put out a match, it got warmer. I want to now isolate those reactions. Can I get each reaction to happen by itself? For example, if I mix these chemicals in different ways, can I get a color change but without the heat or without the gas forming? Can I get the gas to form without the color change? What chemicals are causing the gas to form? What chemicals are causing the color change? So now students need to design their own experiments. They need to engineer an experiment that will allow them to isolate these different reactions. For example, if I add baking soda and water, does it heat up? If I add calcium chloride to water, does it heat up? If I add calcium chloride to water with phenol red, does it heat up? Which chemicals are necessary for each of these separate reactions? So have fun designing your experiments. And if you're not doing this in class, you can simply watch the video and see what happens when we isolate these different chemical reactions. On the back of our lab sheet are a series of 6 questions. The first one asks us, what are the 3 or 4 chemicals that we used in the lab? And obviously that's the baking soda, the calcium chloride, and the phenol red. But remember that the phenol red also contains water. Then the questions ask us to isolate what caused the different reactions to occur. For example, what caused heat to occur? What caused the gas to form? What caused the color change? So let's start to isolate these chemicals now and see what they do. First of all, I have a thermometer in here, and I'm going to pour in some water. So this would be the water without the phenol red in it. And I'll get a starting temperature, then I'm going to add some chemicals to it and see what it does. I'll add them one at a time. So currently our temperature is about 22 degrees. I'm going to drop in a spoonful of baking soda and see what it does. And the temperature is already down to 18 degrees, 17, 16. So that's definitely not causing it to heat up. If anything, it's doing the exact opposite. This is called an endothermic reaction, meaning that it absorbs energy. So that tells us that the heating of the baggie was not caused by the baking soda and the water. Now let's see if we get a color change with baking soda, water, and some phenol red. Obviously, I'm mixing red with a white powder. If it comes out pink, that would be to be expected. But if it comes out another color, then that's the cause of the color change. But when I put it in there, I don't get the yellow color that I got in the baggie. So that means that the phenol red and baking soda are not individually responsible for the color change. Now let's look at phenol red and calcium chloride and see if those will produce the color change. Again, if we see pink, that's to be expected. If we see that telltale yellow color, then we now know what's causing it. And we don't see yellow. So calcium chloride and phenol red by themselves don't create a color change. That last experiment mixed phenol red, calcium chloride, and of course the water that's in the phenol red. Let's remove the phenol red and just mix water and calcium chloride and see what happens. This time I won't expect a color change since I didn't get it before, but what I want to see is if this is what's causing the heat to occur. So I'll get a starting temperature on my water, and then I'll add a spoonful of calcium chloride and we'll see what the temperature does. Currently, again, the water temperature is about 20 degrees Celsius. When I add the calcium chloride, my temperature is 25 degrees, 26, it's past 30, it's at 35. My temperature is creeping up on 40 degrees Celsius already, and it just passed that. So now we know what's causing that exothermic reaction. Right now, what we have in here is the mixture of the calcium chloride and the water. And it turns out that is causing the heat to occur in this experiment, the exothermic reaction. So to the calcium chloride and water, I'm now going to add some baking soda and see if we get a color change or if we get the foaming gas that we saw in the baggie. And when I add them, There's that foaming that we saw earlier in the baggie, but no color change. So this tells us what chemicals have to be necessary for the color change, and also what chemicals are necessary for the gas to form. And notice that the match goes out immediately when I get it near that gas. So whatever that gas is, it must not be oxygen, and it is what's causing the match to go out. At this point, you have all the data necessary to isolate these different chemical reactions on your lab sheet.